This video we're going to look at solution methods for second order difference equations. These are interesting because of the possibility that they generate cyclical solutions through complex roots. For example, suppose we've got the difference equation given here. We solve for its roots by taking the characteristic equation, which in this case is lambda squared plus 2 lambda plus 5 equals 0. And this can be shown to have complex roots. We've got lambda equals minus 1 plus or minus 2i, where I is the square root of minus 1. Now to find the solution here, we first find the modulus of these roots, which is root 1 plus 4, or root 5, and we find its argument. The argument is equal to the tan inverse of 2 divided by minus 1, which is approximately equal to minus 1.1071. We can now write down the solution of this equation. We've got yn equals root 5 to the power n multiplied by a constant of integration c1 times cos of minus 1.1071 multiplied by n plus another constant of integration c2 multiplied by sine of minus 1.1071 multiplied by n, and this will generate a cyclical solution. Now, if we want to solve a non-homogeneous second order equation, then the solution method is very similar to that for first order non-homogeneous equations. What we do is we solve the homogeneous equation and then we find a particular integral. So our general solution for the non-homogeneous equation is equal to the complementary function, which is the solution of the homogeneous equation, plus a particular integral. To find the solution of the homogeneous equation, we again take the roots of the characteristic equation. So we write down the characteristic equation of this equation here, which is lambda squared plus 1 over 6 lambda minus 1 over 6 equals 0. And we can show that the roots of this are equal to 1/3 and minus a half. And we can now write down the solution for the homogeneous equation very easily. We've got yn equals constant of integration c1 multiplied by 1/3 to the power n plus another constant of integration c2 multiplied by minus a half to the power n. Now to find a particular integral, again we in this case, because it's just a constant on the right hand side, we assume that y is constant, so we're looking for yp plus 1 over 6 yp minus 1 over 6 yp equals 2. Of course these second two terms immediately just cancel, leaving us with a particular integral yp equals 2. So our general solution for the non-homogeneous equation is the sum of the solution for the homogeneous equation, c1 multiplied by 1/3 to the power n plus c2 multiplied by minus a half to the power n plus the particular integral 2.